So we just barely started last time talking about how to graph tangent, and then we have to get into reciprocal functions. So graphing tangent, and then 3 other functions. When we graph tangent, you want to think of tangent, at least for the starting graph, tangent is sine over cosine. So when you're first starting to analyze the tangent graph, you think of this as sine x and cos x. Sine x over cos x. What's going to happen with tangent is wherever the denominator is 0, you have a vertical asymptote, and wherever the numerator is 0, you have a 0 or an x-intercept. So what's very important to be able to graph tangent is to find out where the numerator is 0 and where the denominator is 0. So a related kind of problem is figuring out your vertical asymptotes, which was when cos x equals 0, and your x-intercepts, which is when sine x equals 0. Where does this happen, and why? On the unit circle, cosine is the x value or the y value? X value. So your x value on the unit circle is 0 here and here. Right? So this is 0, 1, 0, negative 1. And what angle is this right here? 90 degrees or pi over 2, if we're wearing our big boy radian pants. If we go this way, what angle is this? If you go down, it's negative pi over 2. So those are 2 easy asymptotes for tangent. It's not all the asymptotes, but those are the easiest. And that's enough for one period, because one full period of tangent starts from here and goes here. Right? The period of tangent is pi. So when I graph tangent, for now, let me just use these 2 asymptotes. And then for x-intercepts, sine is the y value. Where's your y value 0 on the unit circle?
Pi, 2 pi.
Any multiple of pi, any whole number multiple of pi. Right? If you land here, which is at 0 radians actually the first time, that will give you a y value of 0. If you land here, which will also give you a y value of 0. This could be at pi radians if you go this way. So for sine x equals 0, my first x-intercept is going to be at the origin, at the angle 0. This is the one I'm going to use. And that, I mean, to get you a quick sketch, that's pretty much all you need. Here's tangent. Y equals tan x. Here's negative pi over 2. Here's pi over 2. What am I going to put there? Dotted lines, asymptotes. Right? Somehow I'm going to indicate that my function shoots off to infinity. And then what does this tell me? The fact that sine is 0 at 0 radians. What point is that on my graph? The origin. Right? When the angle is 0, sine is 0. That means 0, 0 is on my graph. And then really you just have to remember the shape. It's a snake. It goes up like this, down like this. It's tan x. Have to know these asymptotes. It turns out to be massively convenient to also know what happens at pi over 4 and negative pi over 4. So how might I figure out what happens at pi over 4 and negative pi over 4? What? Who? Plug it in. What happens when you plug pi over 4 in a tangent?
Get 1.
Whoa, whoa, okay, okay. Right. See where we're at.
Oh, 1 over 1.
So, we have this, we have pi pi over 6, pi over 4, pi over 3, 1, 2, 3, 1, 2, 3, 2, root. So tangent at pi over 4 is y over x. So when you divide this guy by itself, you get 1. Oh, okay, good. That was a little more. Good. A little stronger. In fact, the tangent values around the unit circle increase. So the first one's root 3 over 3. Then it becomes 1. And then it's no longer, and then it's root 3. All right, so the first one's a fraction, then it's 1, then it's something bigger than 1. But that's okay, I just need pi over 4. So at pi over 4, tangent is 1. And what happens at negative pi over 4? It's negative 1. Why is that? That's what we said, Josh.
Superior to pi.
Well, negative pi over 4 is down this way. So in this quadrant, you're going to be at root 2 over 2, negative root 2 over 2. So when you divide these, you're going to get negative. Technically speaking, this isn't the whole graph of tangent. Right? This is only one period. Because I've only gone from negative pi over 2 to pi over 2. But that's a distance of pi, so this is one period. What would I have to do, though, if I wanted another period? You'd have to repeat everything. You'd have to do exactly what you see there again. So, to make sure you understand what I mean, let's do this. Where would my next asymptote be? 3 pi over 2. How'd you know that?
It's negative pi over 2, pi over 2 is 1. Or it's pi.
Right, it's pi between these two, so you'd have to add another pi to get your next asymptote. So let me do some scratch work. Right, everything for tangent repeats after pi. So pi over 2 plus pi is pi over 2 plus 2 pi over 2, which is 3 pi over 2. Or you can think your next asymptote is going to be down here, which is 3 pi over 2. You go this way. But if I wanted another asymptote for tangent, I'd come over here to 3 pi over 2. What do you think these tick marks are going to be and why?
The same as the other period?
So am I going to label this pi over 4 again?
No.
No. What's going to happen?
It's going to be 3 pi over 4?
It's going to be 3 pi over 4. Why?
Added a pi?
You add pi again. You just add pi to everything. If you take negative pi over 4 and add pi, you get 3 pi over 4. If you take 0 and add pi, you get pi. Thank you. If you take pi over 4 and add pi, you get 5 pi over 4. So 3 pi over 4. Pi. 5 pi over 4. Just adding pi to all of these. And then I repeat the exact same shape. 0 in the middle. Snake. You'll have a 1 down here. And a 1 up here. Negative 1 and positive. It will sometimes be handy to be able to graph 2 periods of tangent. Okay, so hopefully that wasn't too difficult. And we'll do it again as we get to some more examples. But this is kind of your starter graph over here, right? Between negative pi over 2 and pi over 2. That's your usual tangent graph. Then if you happen to need another period, you graph the same pattern again. Yeah? You guys gonna do that?
Yeah.
We'll see. I guess not till next week, but we'll see. One thing that you want to notice, at least to graph more complicated tangent functions, is the structure here. Just like sine and cosine, something important happens every quarter period. So what I mean is, starting from this 0, the whole period is pi, right? So what's the quarter period here? Pi over 4, right? That quarter period means just divide it into 4 pieces. So if you go 1 quarter period, on a tangent graph, you get out 1. If you go 2 quarter periods, you get asymptote. Same thing if you go to the left. If you go to the left 1 quarter period, you get out -1. If you go to the left 2 quarter periods, you get out asymptote. So to graph tangent, to graph more complicated tangent functions, we're going to kind of follow the same pattern we did before. We'll find the period and the quarter period, and then break our graph into 4 sections. So I try to describe the procedure here to you. To graph y equals a tan bx minus c. Right, so now we're talking about more complicated tangent functions. First, we want to find the new period. For tangent, because the original period of tangent was pi and not 2 pi, the new period is pi over b. Right, that's different than sine and cosine. Sine and cosine were 2 pi over b. Tangent's a little different, you know? Now, next I say find the new 0. Okay, so what I mean is, depending on this c value and this b value, this 0 is going to move. This guy right in the middle, he's going to move. Now, we no longer use the terminology phase shift because tangent's not a wave like it does. Phase shift is a term that's used when you have like an ocean wave, like a wave. So we don't use the term phase shift with tangent, but this is the same thing as the phase shift. Okay, the second part here where it says find the new 0, 0, 0 moves to c over b 0. It's the same thing as a phase shift. Right, so depending on this c and this b, your tangent graph's going to move left and right. Once you have the period and the new 0, you're going to break your period into quarters. Just like before. 1 quarter period to the right. 1 quarter period right. On this original tangent graph, when we went 1 quarter period to the right, we got out 1. On this new tangent graph, when you go 1 quarter period to the right, what do you think you're going to have? 1?
Positive
A. A. Right? Because you're multiplying by A in front, when you go 1 quarter period, you get out A instead of 1. Two quarter periods to the right, then what do you get? Asymptote. Always when you go 2 quarter periods for tangent, you get out asymptote. So 1 quarter period, A, 2 quarter periods, asymptote. If you go to the left, what do you think changes? Then you get negative A out. 1 quarter period left, the opposite of A pops out. 2 quarter periods left, asymptote. So that's how you build your tangent graph. Exploit this quarter structure just like before. Woo! Yeah, go tangent, I'm so happy. You guys pumped or what? Sure. Sure? I think. What is this guy doing right now? Alright. Let's graph us a tangent. Graph 2 periods of the function y equals 3 tan x minus pi over 4. let's see, we have y equals 3 tan x minus pi over 4. So I'm going to start just like before, labeling my ABCs. A is 3. What about B in this case? 1, because if there's nothing in front of the x, you pretend there's a 1 multiplying. And then C, positive pi over 4 or negative pi over 4? Yeah, C is always the opposite sign of what you see. All right, now I'm going to calculate my new period. My period for tangent, I'm going to do 2 pi over b. Just pi over b for tangent. Because b is 1, this is just pi again. While I'm here, I'll go ahead and calculate my quarter periods. We do the period over 4, so your quarter periods are pi over 4. Now we have to figure out where that origin moves, right? We had the point 0, 0 on tangent, but it's going to move to c over b0 because of this phase shift-like guy. So we're going to move to pi over 4 divided by 1. Let me put c over b first. We're going to move to c over b0, which is equal to pi over 4 over 1. Since b is 1. So this is really just because b is 1, c over b is just pi over 4. And now I have enough info to graph this. Ready? Hold on to your seats. It's going to be a wild ride. So the way tangent graphs, it expands from the middle. So this new 0 is actually the middle of your tangent graph. So what I'm going to do is go ahead and put pi over 4 on my graph. Right, that's my new 0. That's where tangent is going to hit the x-axis right there. And it's going to be a snake. But I'm going to go ahead and mark out 2 quarter periods each way. So if I go a quarter period to the right, what x value do I have? Pi over 2 or 2 pi over 4, right? Because you just add a pi over 4. And if you go another quarter period to the right, you have 3 pi over 4. And as far as my graph goes, when I go 1 quarter period to the right, what y value should I have? 3. Right? When you go 1 quarter period right, you get out the whatever the a value is. It used to be 1, but if you multiply by a, you get out a. So I'll be up here at 3. And if I go 2 quarter periods to the right, what happens? Asymptote. Disaster. I'm going to steer clear of that bad boy. So that's half of it. I've done the right half. 1 quarter period, 2 quarter periods. A, asymptote. Now I got to do the left half. Which means I go left pi over 4. I use my quarter period and count to the left. So if I go pi over 4 to the left, what x value am I at? 0. And if I go another pi over 4 to the left, where am I at? Okay, so talk to me about y values. 1 quarter period to the left, what's my y value? Negative a, the opposite of this number. So down 3. And if I go 2 quarter periods, then you graph it. Some advice when you graph this, I usually suggest doing it in 2 parts. It just makes it look a little prettier. And also, you don't really need to be in a huge hurry to get to the asymptote. Okay, so sometimes people will start graphing this and like really need to get to the asymptote, so it'll look like that. But tangent has more curve to it than that, so it's a little bit more important that you kind of get a nice curve. You'll get to the asymptote eventually. And then down here, you're going to do the same thing. The asymptote eventually. So this is one period of 3 tan x minus pi over 4. In fact, it's just the tangent graph shifted over pi over 4 and stretched by 3. Right? We started at pi over 4 instead of 0, and we stretched it by 3. But this has all my important x values on it. All my asymptotes. Well, 2 of my asymptotes, the main 2. I asked for 2 periods, actually, so we're not done. We have a little bit more work to do, but let me ask you. So far so good, or so far no good? Okay, yawn, stare. Nod. Okay, a few nods. There are a few nods. Okay. So let me go to the left because there's not as much room to the right. So because I asked you to graph 2 periods, I would keep going. If I know my quarter periods, I'm just going to mark them as I go back. Right? I need to go back to 1, 2, 3, 4 quarter periods for another period. And what am I going to mark this guy? Negative 2 pi over 4. Why? Because you subtract the quarter period, you go back to quarter period. Then I go back to quarter period again. I go back pi over 4. I go back pi over 4. I go back pi over 4. Reduce those if you want. Don't if you don't. I'm super picky about that. After I go back a full period, I'll have an asymptote. Then I just draw the same shape. Start from the middle of my period. When I go over 1 quarter period, I'll be up at 3. When I go back 1 quarter period, I'll be down at negative 3. There's 2 periods. Hardest thing you've ever done in your life, or relatively straightforward? Good. I'm glad you agree. Glad you agree that it's relatively straightforward. Any questions? Yes.
On a quiz, if you asked for 2 periods, would it be okay if instead of going back into the negative values, you went
Go to the positive side.
to the positive side?
You can go either side. If I went to the positive side, I'd have to put on here 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, right? I just add pi over 4. So that's my code.
And from the equation, how do you find the vertical asymptote again?
If you want to find the vertical asymptote directly from the equation instead of adding 2 quarter periods, because we didn't do it directly from the equation, right? We said, this is going to be my new 0, and then I add 2 quarter periods to the asymptote. But you can do it directly from the equation. In order to find the asymptote directly from the equation, you take this thing in the middle, and you set it equal to the old asymptote. So tangent used to have asymptotes at pi over 2 and negative pi over 2, right? The original tangent graph. This guy, the OG. Pi over 2, negative pi over 2. Tangent. So if you want to know the asymptotes directly from this equation, then you would have to take this guy and set it equal to pi over 2. So you could solve x minus pi over 4 equals pi over 2. And x minus pi over 4 equals negative pi over 2. So you'd add this over. Pi over 2 plus pi over 4 is 3 pi over 4. You'd add this over. So then negative pi over 2 plus pi over 4 is negative pi over 4. So this is kind of a different strategy to help you find the asymptote of the tangent if you don't like the quarter periods. Try another one? Alrighty. What happens over you? Y equals negative tan 1/2 x minus pi over 6. So we want to graph y equals negative tangent 1/2 x minus pi over 6. Alrighty. So I'm going to find my period and then my quarter periods and figure out also where my zero moves. So period for tangent is pi over b. I guess I should label my a, b, and c, huh? What's a? A is the number in front, which in this case is -1. B is the number in front of x, which is 1/2. C is the number being subtracted, which in this case is pi over 6. So now I can read off my period. It's going to be pi over 1/2, which when you flip and multiply becomes 2 pi. Right, if you flip the 1/2 up and multiply. Might as well calculate my quarter period real quick. So that's just the period over 4. So I do 2 pi over 4. Pi over 2. So everything's going to be spaced out pi over 2 units away. Then I need to know where my graph moves. Right? We called this the phase shift before. Now it's our new 0. Calculate C over B again.